Chapter 2, Unit 3. Let's talk about a histogram. Histograms are used for continuous data. Remember, that's the opposite of discrete data. Histograms are appropriate only for interval and ratio data. You would not use a histogram for nominal data or ordinal data, only interval and ratio data. A regular histogram looks like this. Again, we looked at this the last section. A block histogram is what you see many times. They both mean exactly the same thing. And sometimes you want to just use an easy histogram for class using X's. I would permit you to turn in something like this. Just put an X representing each score you had. A grouped histogram follows the same rules. So here's an example of a grouped histogram. Notice instead of having just one number at the bottom of each bar, you have a group of numbers at the bottom of each bar. Let's look at polygons. Polygons give the same information as a histogram, and they're used only with interval or ratio data. So you can use these instead of a histogram. To construct a polygon, again, you list all the number scores on the x-axis, same as with a histogram. You even include those that have a frequency of 0, same as with a histogram. Notice on the grouped frequency polygon, which is the one on below, instead of using 10-11 to represent one of the intervals, they just said 10, 11, 12. You could do that as well. I think most people commonly put the dash in, like we saw on the histogram page, but either one works. I usually put the dash in to let people know that that's an interval of 10 to 11. Okay, and then what you would do is you would put a dot above the center of each score. And then you would connect the dots with a continuous line. And then the first dot you would draw down to the x-axis at the previous score. And the second dot you would connect it to the x-axis at the next score. On your graph above, the dot was at 1, so you drew a line from 1 down to the x-axis at 0. And the last dot was at 6, so you drew a line from 6 down to 7. The same thing happens when you have a grouped frequency table. Notice the grouped frequency table below the graph. So it ended at the interval 4 to 5. Notice the dot is put in between 4 and 5 because that's the interval. Well, the next interval would have been 2 to 3, so you draw the line down to the middle of 2 and 3. Same thing for all of the other dots on a grouped frequency polygon. You would put the dot in the middle of the interval. So the interval, say from 12 to 13, the dot would go in the middle between 12 and 13. And then you would draw it down to what the next interval would have been, which would have been 14-15. The middle of that is where you draw the line to. So you're basically closing the polygon at each end. So here's your example. I want you to draw a histogram and a polygon. Use these scores. First thing I want you to do is make a frequency distribution chart and then draw the histogram and draw the polygon. Go ahead and pause this video while you do so and then come back and check your work. So here is what my frequency distribution chart would look like. I would also go ahead and put the 0 in for 7 because there are 0 7s. Next I would draw the histogram. There's your histogram. And for the 7 at the bottom, you can't tell, but I would put a black line across the bottom at 0 for 7. And then the polygon, notice I put the dot at 0 for 7 on the polygon. And notice how I brought both dots, the first one and the last one, with the line down to the x-axis when I was finished. Make sure yours looks similar to these. And definitely include that 0 on the frequency distribution chart for the score of x equals 7. Okay, let's talk about a bar graph. A bar graph is used for nominal or ordinal data because there are distinct categories. They don't overlap at all. when you do a bar graph, it looks like a histogram, except there are spaces between the bars to indicate the discrete categories. So nominal data are ones without a particular order, such as the graph shown here with personality types of A, B, or C. You could be one personality type, but you can't be another or another. You're mainly the dominant one. And then you could also use bar graphs for ordinal data, which is non-measurable width. Relative frequencies can be shown as a bar graph as well. Typically they use percentages. So for example, these owners, how do they view their pet? Well, say like 3% of them view it as property, say 38% view it as a companion, and say 62 or 63% view their pet as family. Okay, so this would again would be a bar graph, but we don't know exactly how many people, say in the US or in the world, view the pet as a family, a companion, or property. So instead, we use relative frequencies. So this just tells the percentage of each. Finally, let's talk about a smooth curve. This has no jagged edges. An example of this might be a normal curve. So frequency distribution graphs. When a population is small, scores for each member are used to construct a frequency distribution graph, such as a histogram and a bar graph. When a population is large, it's almost impossible to know the scores for every single member. This is when we use relative frequencies and when we use smooth curves to indicate the scores. Finally, in a normal distribution, remember it looks like the normal curve, is symmetric with the greatest frequency in the middle. And this is a common data structure for many variables, and most of our tests that we're going to learn in this class later in the second part of the semester are going to be using a normal distribution. All right, let's talk about misleading or bad graphs for a minute. Both of these graphs show the same data. Number of homicides. Okay, well, what if a candidate wants to run against the current mayor and he wants to emphasize that there's a huge difference between the homicides? He would show you the graph on the left. Well, what if the mayor says, no, there's hardly a difference at all, they hardly went up at all? He would show you the graph on the right. Well, the one on the right is actually correct because it starts with 0 and goes up. The one on the left starts at 215 and only goes to 230. They're only emphasizing the very top part of the data, so it makes the data look skewed and it looks bad and misleading. Okay, so you want to make sure you have a 0 starting point when you have a graph. And if you can find an example of a bad graph and copy and paste it into a Word document, you can submit it for extra credit. I'll make a category for that online in Canvas. Okay, let's talk about the shape of the distribution. Researchers describe a distribution shape in words rather than drawing it. So symmetrical distribution, each side is a mirror image of the other. A normal curve is one type of a symmetrical distribution, okay, and that's the one shown on the top left. Look at the data on the top right. Look at that distribution. It has two humps. However, if I draw a line down the middle, does the left side look like the right side? Is it symmetrical? Yes, it is. It's symmetrical, but it doesn't have to be normal. All right, let's talk about a skewed distribution. This is where scores are piled up on one side and then very few scores are in what's called the tail. It just kind of tapers off. So if the tail is on the right, where the high scores are located, think of it as a number line, then it's called a positive skew. The tail is where the skew is. If the tail is on the left, where the low scores are, that's called a negative skew. Okay, now I want you to look at these true or false examples and tell me if you think each one is true or false. Pause the video and then come back and see if you are correct. Okay, so the first one is false. Marital status would be a nominal variable. And have to use a bar graph for nominal data. The second one is true. Time is a continuous variable, it's an interval variable, and you do use a histogram or a polygon for interval variables. All right, learning check. See what you can get for this one. Pause the video while you do so. There's your answer. Measurement scales by frequency distribution polygons are used for either interval or ratio scales. Problem 2, pause this. So in this example, there are more high scores than there are low scores. So the distribution would be skewed, or the tail would be coming off on the low side, which would be on the left side of the number line. So it would be called negatively skewed, because the left side of the number line is more toward negative numbers, the right side of the number line is more toward positive higher numbers. All right, learning check 3. Pause the video. We talked about this a few minutes ago. When you don't know the actual number of individuals in a category, and we have like huge populations, you usually use a relative frequency. And the last learning check problem. Pause the video. Okay, in a distribution with positive skew meaning the tail is off on the positive side or on the right. Where are the scores with the highest frequencies located? Well, they're located on the left side of the distribution because the positive skew where the tail is on the right side. And just for future reference, where all those scores are located is called the body. It's the bigger area of the graph is the body, and the small area is the tail when you're talking about a skewed distribution.